Hi there guys, welcome to today's recording. We are going to go through the NCEA Level 1 2020 Acids and Bases examination paper. So like always, if you have been watching my videos and if you've been finding them helpful and not subscribed, please do so. Right now, do me a favor, help the channel grow so you can reach out to more students. So, you know, the bigger the channel, then obviously the more students that I can reach out to and you know, help them out, especially during this difficult time. Okay, so without further ado, let's just get into it. So question 1 of the Acids and Bases paper. So the Acids and Bases paper, the level 1 science papers are pretty much the same every single year. So it's all about just, you know, I strongly recommend you to grind through at least 3 to 4 past exam papers before you sit the real thing, before you did end up setting the real thing to this year. But yes, very recommended that you do attempt them, because, you know, as a marker myself, you know, sometimes we just keep the old marking schedule because the questions are so similar. All right, so let's look at number 1. Number 1, sodium and oxygen elements, blah blah blah, use the information supplied, draw the electron arrangement. Okay, so this number right here, that's on the top left hand side, so that I always tell my guys to do this. I normally tell them to do pen, protons, electrons, neutrons. The protons is exactly the same number, like say for example Na. The P stands for 11 protons, so this is just the small number on the top left hand side. Sometimes you can put on top on the bottom left hand side, but it doesn't really matter. It's always a smaller number. Okay, so there's 11 protons, 11 electrons, because the protons are numbers and the electron numbers are the same. If you have 11 electrons, so you arrange them in the format of 2, 8, 1. Draw the electron arrangement. So this is rather boring, so I just want to draw like 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, and then the third shell takes 1. Okay, because there's only 1 left. So the first shell can take a maximum of 2, second shell can take a maximum of 8, third one can technically take a maximum of 8 as well, and then the leftover, you just chuck them in the fourth shell because you don't learn anything more than 20 anyway. Oxygen, same thing. Oxygen is 2, 6, because I got 8 protons. You're writing with a pen, 8 protons, 8 electrons, so it's 2, 6. Okay, so this is going to be 1 and 1, 2, 3, 4, 5, 6. And as you can see, this is just coming from a habit that I try to space out my electrons as, you know, further away from each other as possible, because they are negatively charged, so they're supposed to repel each other, but it doesn't really matter in this case. Next one, so sodium ions and oxide ions have the same electron arrangement. Okay, so one is 2, 8, 1, one is 2, 6. So this is a question I always ask my guys, you know, when you're sitting on 2, 8, 1, what is it? So why do they become ions? Is that they want to have the same, they want to have a full outer, so this is a key word that you do need to remember. I don't think they asked it this year, but you want a full outer shell electron. Oh, sorry, a full outer electron shell. Outer electron shell, you want it to be full to become stable. Okay, so this is a you know, like I mentioned before, as a marker, this is something I look for. Well, something that our entire panel looks for. We want you to talk about why do atoms become ions. Is that they want to gain, they want to have a full outer electron shell in order to become stable. Okay, so this number is not 8, so what can it do? It can either lose 1 or gain 7. Losing 1 is much easier. It loses 1, so it becomes 2, 8. That's not full, so how does it become full? You gain 2, so it's 2, 8. Okay, so this is both 2, 8. And how do they have the same electron arrangement but different charges? So this is where they're just asking you the same question that compared to previous years, it's pretty much the same question. I just tend to teach my guys using this, and it works quite well. If you got sodium, you got oxygen, yeah? So this is 11, this is 8. This is what I normally do. So from the 11, I have pen, PE, PE. You all do PE, you should know what this stands for. So protons, 11 electrons. This is 8 protons, 8 electrons. Yeah, so we know this is 2, 8, 1, this is 2, 6, 281, what it's going to do, it's going to lose 1, become 28. So how many electrons does it have now? You have 10 electrons. I still have 11 protons. Remember, the proton number doesn't change. So if you look at these two numbers, 11 positive protons, 10 negative electrons, you have one more positive protons than the negative electron. Oops, the negative electron. So what does that mean? That means Na is going to be +1. In comparison, sodium is 2,6, so it wants to become 2,8. So I still have 10 electrons, but then I only had 8 protons to begin with. So as you can see, I have 2 more electrons than protons. Okay, so what does that mean? That means I have 2 more negative charges, so it's going to be O2 minus. Okay, so something I really want to point out to you guys is that, look, you need to follow the question. We want you to, whenever it says refer to the number of protons, charge, and electron arrangement of the two ions, we want you to include that in your final answer. So you can talk about, yeah, they gain electrons, lose electrons, to become stable, but if you don't tell us the number of protons, you're not going to get the excellence. Okay, because trust me, as a marker of, marked over 800, 900 papers every single year, this is what happens that we look for. So if you do my method, you can see that I clearly laid out my protons numbers here, just as a supplementary evidence. Then it will be quite handy. Okay, so if you look at the mod answers here, so why do they? So sodium losing electron to have a full outer shell becomes stable. So Na forms Na plus ions because it has 10 negative electrons because you lost 1, you still have 11 positive protons. And oxygen, in comparison, they need to gain 2 to have a full outer shell to become stable. It gains 2 electrons, so now it has 10 negative electrons, 8 positive protons, so they have 2 more negative electrons, therefore the charge is O2 minus. Okay, so that will be a very, very, very common excellence question that comes up every single year, so make sure you can do this. Okay, moving on. Next one, 2 unlabeled color solutions are known to be sodium hydrogen carbonate. All right, so straight away, before we talk about it, as a year 11, you just need to know carbonate, bicarbonate, any carbonate, like hydrogen carbonate, just carbonate, and then the hydroxide. Now, this is not completely true, but you only NCEA level 1 students, so I'm just being very pragmatic here. Whenever you see something like this, something oxide, hydroxide, carbonate, these are bases. Okay, if you see something blah 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 acid, then it's obviously a base. It's obviously an acid. Then the ones that's not in the 2 categories, those things are neutral. Like say, so for example, you got sodium hydrogen carbonate. This is a tricky question because they give you this, they go sodium hydrogen carbonate, they give you sodium hydroxide, and then people always go, oh my god, I know this. I know sodium hydroxide, that must be a base. So they go, all right, sodium hydroxide must be a base. What's sodium hydrogen carbonate? That's, using psychology, that must be an acid. Why would they give us 2 bases? And in this case, it did give you 2 bases. Okay, so you just remember any carbonate, hydroxide, oxide at NCEA level 1 is those are bases. If it's something hydrochloric acid, sulfuric acid, these ones are obviously acidic. And then whatever the other things are, the leftovers are neutral. Okay, so if red litmus paper, this will go blue. This will go blue because they're both alkaline, they're both bases. But then if you react this with sulfuric acid, now carbonate plus acid is going to give you salt, water, and carbon dioxide. Carbon dioxide, you see this as bubbles. Okay, so you can actually see this. So observation, you see bubbles, and this one, no reaction, no observations. It doesn't mean there's no reaction, it just means you can't see anything, because acid plus base gives you salt and water. And then you may go, oh, but you told us carbonate is a base, so why can't I just go acid plus base give you salt and water? But carbonate, your drink, it's a bit unfortunate, but surely all of you would have drank a bit of what do you call it, carbonated drink like Coca-Cola or Pepsi or Fanta. Those things are carbonated, so they got carbon inside, so carbon dioxide inside, so that's why it makes it fizzy. Okay, so those are you see the bubbles when it reacts. Okay, so explain each observation. So it just means that we kind of talked about it here. So you have the carbonate, this carbonate react with the acid will give you CO2 bubbles, whereas the other one, there's no observation because there's still a reaction. You make salt You make salt and water, but you can't see them. Okay, you can't see them. I've seen a lot of people say, oh, you will see this particular salt. No, you won't. You put sodium hydroxide and hydrochloric acid, you're not going to see any solid inside unless you evaporate all the water. Okay, so let's have a look at the answers here. So there we go. Tricky question. So just remember, these are all bases, so they're all turned litmus paper blue. And so you add sulfuric acid, so the carbonate is a carbonate. All right, so what it does is it undergoes neutralization reaction, you produce carbon dioxide, which makes it bubbles. If sodium hydroxide is also a base, but it will not make bubbles because you will just make salt and water. Okay, and here's the word equation, symbol equation. Now if you're only going for achieved, symbol word equation is something you must be able to do. If you are looking to, if you're really confident with symbol balancing symbol equations, you don't even need to do the word equation. A word equation is achieved only. Okay, so you can perfectly leave it completely blank, just do the symbol equations here to get a merit or excellence. All right, but let's just go from the beginning. So this is hydrogen carbonate plus sulfuric acid. So we make salt, water, and CO2. Yeah, so what is the salt? Salt is the metal part of the base, which is the sodium, combining with whatever the acid is. So this is going to give us sodium, so sulfuric acid becomes sulfate, hydrochloric acid becomes chloride, nitric acid becomes nitrate, but in this case it's sodium sulfate plus water plus carbon dioxide. Okay, so if we do the simple, so this is for just achieved. Now if you're someone that's sitting between achieved and merit, like if you sometimes you may like say you're not so confident, I would strongly recommend you to do the word equation first, and then you just translate, like what's sodium hydrogen carbonate. This is where you use your table vines. Sodium is Na plus, hydrogen carbonate is HCO3 minus. This is all on the table vines. So sodium hydrogen carbonate will just be NaHCO3. Sulfuric acid, memorize it H2SO4. Then we make, so can you see, this is just literally translation. See the plus signs and everything gets carried forward because they are the same thing. Sodium sulfate, sodium is Na plus, sulfate is SO4 2 minus. So this is plus 1, this is 2 minus. I need another Na plus to balance the charge. So I got 2 Nas, so this is going to be Na2SO4 plus water plus carbon dioxide. Now if you do it like this that I've just done, you'll be getting a merit. How do you get the excellence? Is that you need to balance this equation. So this is where the balancing part is. Now if you attempted to balance it but you got it wrong, but as long as what we just wrote down like is what you wrote down, you will still get a merit. Like if you attempt to balance it but then you failed, but then the foundation is correct, you still get a merit. So you can give it a go. Just don't touch anything that we just written. All right, so don't touch any of that, just keep it there, but we are going to play with the numbers. So how I tend to do balance equations is to look at the unique atom. So I don't look at the hydrogens or the carbons in this case. I look at the sodium. Can you see there's 2 sodium here and this is only 1 sodium here, so I put a big 2 in front of that. And when I changed that, did I change anything else? Can you see now, because everything is multiplied by the big 2, can you see there's 1 CO3 here, I multiplied by 2, so there are now 2 carbons. On the right hand side I only have 1 carbon here, so that's going to give us 2 carbons on the right hand side. And then let's just double check. Let's look on the left. Can you see there's a hydrogen here? That's 2 hydrogens. There's 2 hydrogens here, and then we have 2 hydrogens here, so that needs to be doubled as well. Okay, so that should balance it. So the final answer should be 2 NaH. Oops, it should be, just get rid of this. It should be 2 Na HCO3 plus H2SO4 turns into Na2SO4 plus 2H2O plus 2 CO2. I think in my previous videos of the older exams, I was more thorough with the balancing equation part. It's more of a, like say, if you're someone that's wanting to get achieved, don't even bother with balancing symbol equation. Just do the word equation. It's your worst investment of time ever. Like if you just want your 4 credits, you just want achieved, spend your time learning the atomic structures, spend your time learning the pH, spend your time learning the rates of reaction. Don't touch the balancing equation part. You're just wasting your time. Okay, I'm just being very pragmatic. You can spend 2 hours on this and you still don't get it. If you're someone that's wanting to push for excellence, you must make sure you get the simple equations right, because for this particular, whenever you have a chemical equation balancing question, they are guaranteed excellence, but you need to find another excellence in the same question to get you E7. So but if you get this wrong, then that really reduces your chance of getting excellence. Okay, so next part, sodium hydroxide plus sulfuric acid. So this is just sodium sulfate plus water. Okay, so this is just NaOH plus H2SO4 turning into Na2SO4 plus water. Again, same thing, I want to balance it. This is 2Na, this is 1Na, so the big 2 in front of there, and then I do a big 2 in front of there because I got 2H, 4 H's, and then on the right hand side I don't have 2H here, so that's why I need to multiply by 2. Okay, next part. Question number 2. So we are looking at some carbonate. Alright, sorry, just checking my school email. Alright, so this is just blah 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 blah. Not really interested. Okay, explain why the rate of reaction at the start of 2 reactions is different. Okay, so I'm just skimming through. A lot of the info is just irrelevant, to be honest. But it does help. Like if you look at this equation, if you struggle with the balance, the word equation above in the equation that we just did, go upwards. Like this, they have given you a sort of like a similar type of reaction. You can use that. Yeah. So they were quite generous here. Okay. So one sample was powdered, the other was chipped. Okay, so chips. So same concentration. So everything else is the same. Everything else is the same. But as you can see, the chips and the stone have got, and the powder, sorry, have different. What do you call it? Have different rates of reaction. So why does the rate of reaction at the start is different? Because surface area is different. Okay, so what is surface area? So when you have stone chips versus powder, powdered has higher surface area, and when you have higher surface area, that just means that the particles, the reactant, like the stone particles, are more exposed, and they are more likely to bump into the other reactant to produce a reaction. If you have something in the form of chips, this has lower surface area, so it is less likely for them to bump into each other. Like, so you think of it like this: if you have a massive chip, like a big stone, and then if you want to react that way, only the outskirt can react, the core can't be touched by the other chemical. So how does that work? So that will slow the reaction down. So you have to eat through the outside part first to get to the inner bit. But if you grab the same stone and then if you grind it up, powderize it, make it into small powders, you put in the acid, it will react much quicker, even though it is the same amount of stuff that you have at the beginning. The powder one have a higher surface area, you have more reactant particles readily available to react at the beginning, therefore you have a higher frequency of reaction. Okay, so the particles must collide. All right, so the powder has more surface area, therefore there's a higher chance for them to collide, therefore there are more collisions per unit time per second. Now you either say per second or you say higher frequency. Okay, just make a note here. You can say there are more frequent collisions or successful collisions, or you can say more successful collisions per unit time or per second. Okay, so frequency is the same thing as per unit time. Now, I gave this example before. I say, if I go, all right, a doctor earns $200,000 a year, a lawyer earns $95 an hour, who earns more money? Then you'd be like, oh, that I can't make the comparison because the time different. The time is the unit of time is different. Okay, so you have to make sure. So this is what the per unit time means. So it could be per second. So the reaction that's got more successful collisions per second it's obviously reacting faster, therefore it has a higher rate of reaction. Okay, now explain why the final masses were the same, because they have the same amount of ingredients. And I love using the chicken example. If you put a chicken in the oven, if you the whole chicken into the oven, bake for a certain cook for a certain amount of time, take it out and it's cooked, versus if you get the same size chicken, exactly the same thing, but this time you chopped it up into smaller slices and then you put it in the oven, and then this one's going to cook faster because it has more areas, like more surface area that's exposed to the heat to the oven, therefore it's going to cook faster. But then at the end, do you get more chicken? Not really. You get the same amount of chicken, because the only thing that's different is how quickly they get cooked. So why the final masses of the two flasks were the same? Because you have the same mass of the ingredients. Okay, so the samples contain the same mass, reacted with the same amount of HCl, you lose the same amount of carbon dioxide, and that means the leftover is going to be exactly the same amount. Okay. Right, next one, the calcium carbonate react with hydrochloric acid, blah, 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 blah. Explain why the ratio of calcium ion to chloride ion in the CaCl2 is different to CaCl3. Okay, so this is something you need to understand. So this is where you need to look at the table of ions. Explain how the ratio is to the charge of the ion. So make sure you read the question. Sometimes they ask you to talk about transfer of electrons, and so this is what a normal question will look like. They want you to do the same question, exactly the same question. They will say, all right, we want you to talk about the transfer of electrons, and also want to talk about the charges. And then normally when you get this type of question, if you do this right, that's a merit. If you do this right, that's a merit. If you do all of them right, this is an excellence. But this is only looking at the charge, so you don't need to look at the transfer electron. And what is the transfer electron? I might as well explain it here, but you don't really need it in this case. Like say, for example, Ca2+. When Ca becomes Ca2+ ion, this loses 2 electrons. Cl1- means this gains 1 electron. Okay, so can you see the Ca2+, the Ca wants to lose 2 electrons, and the Cl wants to gain 1 electron. So does it make sense? I need 2 Cls to gain the total of 2 electrons from the calcium in order to, for everyone to be happy. Therefore, you need 1 Ca2+ per 2 Cl-. So that's the transfer electrons I was referring to. But if they only ask you to talk about the charge, well, you want to talk about this. You want to talk about the ionic compounds. Ionic compounds are neutral. Neutral. So what does that mean? They have no overall charge. The charge will cancel out. So if you have Ca2+ and you have 1 Cl-, this is +2, this is -1. Therefore, you need 2 chloride ion to balance 1 Ca2+ in order for the charge to be neutral. And in this case, this is 2+, this is 2-. You just need 1 of each. They perfectly cancel each other, and that's your formula. Okay, so here you go. So calcium loses 2 electrons because of +2. It needs it needs 2 negative charges to neutralize it, to form a neutral compound. So the chloride has a 1- charge, so you need 2 of that combined together to cancel out the charge. And the carbonate has 2-, and then the oxide is 2-, so you just the Ca is 2+, and then the carbonate is 2-. One of each cancels each other out. All right. Last question. So this is looking at 2 solutions of equal volumes of sulfuric acid were tested using universal indicator. So which one has the more? Okay, so it's red. Now, before we go into more detail, well, it's always red. Just remember the rainbow colors. This is what I normally do. I think I've done this before for the older exam papers as well. Now, again, if you're someone here that wanting to pass, like just want to pass, memorize this. Like, don't bother with the balancing equations. Memorize this. This is your pH scale, 1 to 14. 7 is neutral. Okay, so this is your water, neutral, perfectly neutralized the ion as water. This is colored, universal indicator is green. And then just go with the rainbow colors. 1 to 2 is red, orange, yellow, Roy Gabiff. And we just don't worry about the I, because it's quite difficult to distinguish. So pH 1 to 2, this is pH. pH 1 to 2 is red, 3 to 4 is orange, 5 to 6 is yellow, 8 to 11 is blue, 12 to 14 is purple or violet. Okay, so just remember the rainbow color. You know, even my 5-year-old can remember the rainbow colors: red, orange, yellow, green, blue, violet. Write it down. And then this side, this is your strong acid, not pointing at the 2. This side, yeah, 1's the strongest one. These ones are the strong acids. Okay, so down here is the weak acids, and then down here is the weak bases. So you can think about towards the middle, they're weak, and then on the other end of the spectrum, they are very, very strong. Okay, so what does strong acids mean? Strong acids is that you have lots of the H3O plus ions compared to the OH minus ions. Weak bases means you have more H3O plus ions compared to your OH minus ions, but the difference is not as great. But then when you have pH equals neutral, neutral means that the H3O plus ions equals the OH minus ions. Okay, and when you get to the weak base, that means the OH minus ions is going to be more compared to the H3O plus ions, and the strong base is OH minus is greater than the H3O plus ions. Again, if you're someone wanting to pass, if you get a pH color question, let's say explain why the solution have different colors, and if you have, you know, you've been failing throughout the year, you just really want the 4 credits, you see that thing I just drew, memorize that. That's going to take you half an hour max to memorize. Go in when you have the pH question, chuck that down. All right, I can guarantee you'll get 2 to 3 achieved ticks at least. Okay, because this covers everything. Oh, and if you were going to do this, make sure you know finish the acronym so you know what the colors are. Let's go with purple. Okay, so why solution have different colors? Because they have different pHs. If it's red, what pH? If it's red, that means it's pH 1. What does that mean? That means you have this lots of H3O plus compared to OH minus. And then this one's orange. Orange is pH 3 to 4. What does that mean? That means you have more OH minus H3O plus compared to OH minus, but not that greater of a difference. And that means the pH is a little bit higher. Okay, so it's really straightforward, guys. It's so repetitive. When you get the pH questions, which you always do every single year, chuck it down. Even though you feel like, oh, am I really answering the question? You are answering the question somewhat. Okay, so because remember, we look for evidence everywhere, so this is what you could do. Next one, blah blah blah. Not really interested. All right, what type of reactions? This is something that really annoys me every single year. For this, because I know some schools do other type of do other chemical standards, and they get chemistry standards, and they get the mixed reactions mixed up. There's only one type of reaction that you learn in the standard, that is neutralization. And even if you forgot neutralization, I would like you to turn to the first page of the exam. It will say acids and bases. Just put acids and bases here, and then you'll be fine. That is the easiest achieved tick that you'll ever get. And how many achieved ticks do you need altogether? You need about, you get 9, you guarantee 4 credits. This whole thing is out of 24. All right, you get 9, you guarantee. You get 9 marks out of 24, you guarantee to pass. All right, if you get 8, most of the time that's achieved as well, and 8 out of 24 is 33.3%. And if you really can't get 33.3%, you really don't deserve the 4 credits. But then that's where I come into trying to help you to get there, because 4 credits is better than 4 achieved credits is better than no credits. All right, last one, explain why reaction occurs quicker with warm sulfuric acid. Okay, so just remember, when it's warmer, which means the particles have more kinetic energy. All right, they have more kinetic energy. What does that mean? They move around more. If they move around more, what does that mean? They're more likely to collide. More likely to collide. If they are going to collide, what does that mean? That means you have more collisions per second. Now, because these particles have more, because these particles are colliding with more energy, they're colliding with more energy, more collisions per second, and because they have more energy, more collisions will collide with sufficient amount of energy. Sufficient amount of energy. I'm running out of space. I really need a bigger tablet. So that means higher rates of reaction, or more effective collision per unit time and higher rate of reaction. Okay, but this is what you're looking at. This is twofold, all right? Because a lot of people just go, oh, there's more heat kinetic energy, the more fast, the more likely to collide, boom, higher rates of reaction. You will get a merit with that sort of answer, but you need to talk about the other aspect as well. Okay, so let's look at the Newton writing. So particles move faster, they have more energy, so more collision per unit per second because they're more faster, and more of these collisions have enough energy to cause a reaction, therefore increasing current cause more 6 sets of collision per unit time, and the reaction will occur faster. So as a marker, if you do this line here, this is merit. If you do this line here, this is merit, and then if you do them together, it's excellence. Okay, so rates of reaction, especially if you're planning to do some level 2 chem next year, do well in rates of reaction because that's going to help you significantly next year. It's probably one of the few things that will get carried forward to your level 2 chem. Alrighty, so that's the end of the examination paper. I hope that you found this video somewhat helpful, and feel free to leave a comment in the comment section if you get confused with any of these stuff, and I'll reach out, and then we can give you more assistance so you can do better in the upcoming examination. Okay, so all the best, and I'll see you guys next time. Bye bye.